Hello everyone. So today we are going to discuss one numerical of Naval. Okay, and this question has been asked several times in exam. I'm not going to take the year's name and so. So the question is, see, a box barge 45-meter long and 15-meter wide. Okay, it floats at a level keel draft of 2 meter in seawater. Okay, the load being uniformly distributed over the full length. Two masses each of 30 tons are loaded at 10 meter from each end and 50 ton is evenly distributed between them. Now sketch shear force and give maximum shear force. Okay, so we'll just go about it, and then first what we are supposed to give is now what is given to us. So please bear with my handwriting. So given is length. So length is how much? Is 45 meters. And now when we speak about breadth is 15 meter. And then they are talking about the draft. So draft is how much? Is 2 meters. Okay. Now just as it says that it's a box barge. So we are going to draw one box barge. Okay. Now see, this box barge, when we talk about, now this is the box barge. Now they say that 10 meters. See, I will just first draw it and then we'll explain it to you. So from the end, now I will name it as A, B, C. Sorry, C will take one at the middle, C, and then this one is D, and then we take it as now 30 tons, 30 tons, 30 tons. Okay, now this is E point. Now they are talking about box barge 45-meter long. So this total length is how much? Is 45 meters. Okay, now this is 45 meters, and then now they talk about 2 meter draft. Okay, so this will be L, and then water line, then we are drawing this water line. Okay, this is L1 and this is water W and water line, so we are referring it to as next. Okay, now see, they tell that the load being uniformly distributed over the full length, two masses each of 30 tons are loaded at 10 meters. So 13 from the end, from the each end. So this is the end, and from the end it is loaded at 10 meters distance, this 30 tons load. Okay, so this will be 10 meters. Now here also it is 10 meter, and now it is loaded here. Okay, now total length is 45, so 10 plus 10 20, so 45 minus 20, that will be 25. So we get the middle length also, which is to be 25. Okay, now they say, okay, 50 ton is evenly distributed between them. Now 50 ton is evenly distributed between these two 30 tons. So this is the case. Now 50 tons is evenly distributed, so I will shade this diagram so that it is convenient for us to note, and I will write here 50 tons. Okay, so this 50 ton is evenly distributed here. So if we take it as a line diagram, so then it is how much? It is number 1 point, number 2 point, number 3 point, number 4 point, and number 5 point. This is 10 meters. So here the load is acting 30 tons. Here the load is acting what is known as 30 tons. Okay, now here also it is, the distance is 10 meters. Here distance is 10 meter. Here also the distance is 10 meter. Okay, this is 25 meters. Now this is clear. Now here it is load 50 ton is evenly distributed, so I'm writing here 50 tons. Now, since initially the load is uniformly distributed along the vessel's length, there will be no shearing force. So initially the load is evenly distributed, because the question only says that initially the load is evenly distributed. So there will not be any shearing force. Okay, after addition of masses there will be shearing force. So when we add these mass, then there will be shear force. Okay, there can be numerous methods, but what we are supposed to discuss is what you are supposed to do in exam. Okay, so now we will first calculate the total mass total mass on ship. that will be how much is 30 plus 50 plus 30. Now it is 110 tons. Okay. Now when we speak about total buoyancy force, now we also calculate is total buoyancy. Total buoyancy force when we calculate, that will be how much? 110 ton, or we refer to it as 110 gram kilo Newton. Okay. Now buoyancy force, because we'll take it as per meter in unitary method for our calculation of shear force. Buoyancy force per meter, okay, is 110, and the total length is how much? 45. Okay, so it will come out to be what is known as 2.444 tons per meter. Okay, or in other unit, 2.44 gram kilonewton per meter. Okay, now one thing we have to remember is force upward. Okay, force in upward direction will always be positive. This will come convenient while calculating. And force acting downward, so when we speak about downward, then that will be negative. So these are very important and key point that we are supposed to remember. Now we'll start calculating the shear force. Now SF1, okay, SF1 is this point, okay, this point. So here there is nothing, the shear force will be 0. Now we take number 2 point, shear force at number 2 from the left direction. From the left direction, when we calculate shear force from left, I am referring to it as L. Okay, shear force to L, left. Now this will be how much? Shear force when we calculate from the left direction is positive 10. The distance is how much? 10 into 2.44. Okay, 2.44 and then minus 0. So this will come out to be what is known as 24.44 tons. Okay, now again we'll shift our focus to shear force SF2. Okay, when we shear force SF2, and that will be from right direction. So when we speak about shear force from the right direction, so this will be 24.44, which is there only, and then minus, that is what is known as is 30. So this 30 tons that is being acting. So it will be how much? Minus 5.56 tons. Now we go for SF3 is equal to minus 30. Okay, minus 30 minus 50 by 2. Okay, plus, now because third position, if you recall, this third position is at the middle portion. Okay, so that is why this total 50, that will be divided by 2, and then plus we go for it is known as 25 by 2 plus 10, okay, multiplied by the shear force acting per meter. Okay, now we close the bracket. Now we will calculate is equal to minus 30 minus, this will be 25, 50 by 2 is 25, plus 54.99. This you calculate, it will come out to be 54.99. So SF3 at the middle, it will be somewhat similar to 0. There will be some point, so that we ignore it. Now we go for SF at fourth position, SF4. Okay, what was the fourth position? This is the fourth position. Okay, so we go here SF4. Now here also, both the place where the force is acting, we will calculate from left end and from the right end. So SF4 from the left, when we go, is minus 30 minus 50 plus, then bracket, what is known as 25 plus 10 into 2.444. okay, now we close the bracket, and then we see it will come out to be 5.56. 0.54 ton. Okay, now SF4 from right, when we calculate, is minus 30 minus 50 minus 30 plus what is known as 25 plus 10, okay, into same 2.444. I hope it is clear. So the video doesn't get lengthy, so things are which are already discussed, we are not repeating it. Okay, now again SF at fifth position, that is the last end. Okay, so here it will be minus 30 minus 50, and then we move on to minus 30 plus 45 into 2.444. 45 is the total length and 2.44 is the, so this will come out to be 0. So same, so SF at 1, the starting position 0, SF at the other end SF5, that is also 0. Okay, at the midpoint SF3, that is also 0. Okay, so we got what is known as, so now based on this we are going to draw what is known as the shear force diagram. Okay, so for drawing shear force diagram, so we take a simple plain line. Okay, draw a plain line. Now shear force at first position is how much? Is 0. So we write here 0. Now at this position, so it will be how much? It was 24.44. We calculated SF2, so you can refer the video. 24.44. Okay, now this is upward positive, so we are putting here positive. Downward negative, shear force 2, it came out to be 5.6, and then 0, it was 0 at third position. Okay, now here you go, how much it was shear force? 5.6, same 5.6, so it will go and coincide here 5.6, and then it will go again same 24.44, and then again at fifth position it is 0. Okay, this is negative, this is positive, this is negative, this is positive. Okay, 5.6, 5.6 and 24. So the maximum shearing force. So now the question was the maximum shear force occurs at what position? 2 and 4. Okay, maximum shear force occurs at 2 and 4. Now when we talk about the value of SF is 24.44 multiplied by this 9.81, this comes out to be 239.75 kilonewton. Now which is similar to what is known as 239.8 kilonewton. Now this is the answer for maximum shear force. So these were the two pertinent questions, that where it is occurring. So it is at 0.2, okay, and 0.4. Okay, 0.2 and 0.4, one is the upward, there is the negative. So and the maximum shear force, it is there. So I hope it is clear for you. Okay, you can pause and see the video. Thank you so much.